So let's look at the next one in this section. It's 2010 Form B. It talks about two particles moving along the x-axis from 0 to 6, and it gives you two position functions, the p t, and the position of particle r is r of t. And this is a non-calculator. So part A says for 0 to 6, find all the times which r is moving to the right. So remember, you want to get the derivative of r. So we're just going to come up here and do our power rule because this is a non-calculator. So you'll get the derivative, and then I factored it, set it equal to 0, and then I'm going to do a sign chart. So I'm going to do my endpoints 0 to 6 and my 1 and 3. And then I'm going to do test values. I used 1/2, 2, and 4. And remember, on a non-calculated part, you can put your two factors and then just plug it in. So 1/2 in here makes negative. 1/2 in here makes negative. Negative times negative makes positive. I put 2 in here, I've got negative. 2 in here, I've got positive. Negative times positive makes negative. And if I put 4 in both of these, they're positive, and it's positive. So it talks about where it's moving to the right. So it's moving to the right where velocity is positive. So it's moving to the right from 0 to 1 and 3 to 6. Now part B says find all the times where the two particles travel in opposite directions. So you already got the direction for r. Now you got to take the derivative of 2 cosine. So the derivative of cosine is sine of pi over 4t. The 2 was already there, and remember the derivative of cosine is negative. And then times the inside, or the angle, which would be the derivative of the angle would be pi over 4. So this is going to be my first derivative or velocity function. So I'm going to set that equal to 0. And you ask yourself, where is sine 0? At 0 and pi. So I take my angle and set it equal to that. And I get my times to be 0 and 4. So I'm going to do my endpoints in 4. I use a test value of 1. If I put 1 in here, sine of pi over 4 is in the first quadrant, so it's positive. Times negative makes negative. If I put 5 in here, 5 pi over 4 is in the third quadrant, which means sine is negative. Negative times negative is positive. So then I'm going to compare these two charts, and if you do, you get that they're in opposite directions, 0 to 1 and 3 to 4. Now part C says find the acceleration at t equal 3. Is the particle p speeding up, slowing down at t equal 3? So remember, we got to look at velocity and acceleration. So you've already got the velocity. So you're going to take the second derivative to get acceleration. So the derivative of sine is cosine pi over 4t times the derivative of the angle, pi over 4, and negative pi over 2 was already there. So we're going to get this as our second derivative. So we're going to plug 3 in, and we get this, cosine of 3 pi over 4. And so that's in the second quadrant, so that means cosine is negative. Negative times negative makes positive, even if you didn't remember the exact values. And if I put 3 in the velocity, I get sine of 3 pi over 4. Again, that's the second quadrant, so that's positive times negative makes negative. So since these signs are different, it's slowing down. Now it says write, but do not evaluate an expression for the average distance between the two particles on the interval. So remember, distance is the absolute value of velocity. So you would put the derivative, subtract the difference in those, and then 1/2 would be algebra. 1/2 would be the average. So the next one is they give you the graph of the velocity. They tell you the values of the areas of each of these. And they tell you that at the starting position, the particle's at -2 at time equals 0. So part A says from 0 to 6, find both the time and position when the particle is farthest to the left. Now think about that. you're going to be left when velocity is negative. So the farthest left is going to be at t equal 3 before it changes positive. So you got t equal 3. Now how do I find my position there? I go to my original position from 0 to 3 of v of t. Remember, position is just plain velocity, not absolute value of velocity. That's distance. So it told you x of 0 is negative 2. Now you come up here and it tells you that it's 8, but remember that's area, and area is positive. If we're evaluating the integral, it's below the x-axis, so we have to put negative 8, and so we get negative 10. For b, it says how many values of t is the particle at x equal negative 8? So that means where is it a position at x equal negative 8? Well, think about this. We know x of 0 is negative 2, and x of 3 is negative 10. Negative 8 falls between those two, and the function is continuous. So it has to have crossed what? Negative 8. Now let's look at our next little section. X of 3 is negative 10. X of 5, we're going to come over here and do x of 3 plus 3 to 5. So, you know, it's negative 10. You know, this was 3 and it's positive, so you get negative 7. Again, you're moving from negative 10 to negative 7, so you're going to cross negative 8 because it's moving continuous. And then our last interval, x of 5 is negative 7. X of 6, we're going to come up here. X of 5 is negative 7. We're going to go from 5 to 6. We told you it was 2, but it's underneath the x-axis, so it's negative 2. So you get negative 9. So you do see that it falls there. The theorem that lets us do that is the intermediate value theorem, because it says if you have a continuous function from a to b, there'll be a value that falls between f of a and f of b. All right, so C, on the interval from 2 to 3, is the speed increasing or decreasing? So we're going to use the graph here. So from 2 to 3, your velocity is negative. And what about acceleration? Well, the relationship between first and second derivative is if the first derivative is increasing, the second derivative is positive. So that means your velocity is negative, your acceleration is positive. So it's slowing down because the velocity and acceleration have different signs. And it says during what time intervals is acceleration of the particle negative? Again, you're going to use your graph. Acceleration is going to be negative where velocity is decreasing. So it is, if you look at the graph, it's decreasing from 0 to 1 and from 4 to 6. And so that will be where it's negative. Now let's look at our 2007 one. This is a non-calculator. It says a particle is moving along the x-axis, and this is the position function from 0 to 2 pi. It says find time where the particle is farthest to the left. So we want to find velocity and get our sign chart. So we're going to take the first derivative. Now we're going to have to use product rule. So the derivative of e to the negative t is e to the negative t times the derivative of the exponent, which would be negative, times sine of t, plus the derivative of sine is cosine t times the e of negative t. So if I bring that out, I have this. Well, e of t won't be e to the negative t can never equal 0. And this will be where cosine equals sine. And that happens at pi over 4 and 5 pi over 4. First quadrant and third quadrant, because that's when cosine and sine have the same signs. And so, and has the same values. And so we're going to do our sign chart, and we're going to come over here and we're going to put our endpoints and our two values. And so we're going to pick a test value. It doesn't matter what test value you put here. You know that they're both positive in the first quadrant, which is that where that's going to fall. So if you put that, whatever the value is, this is going to be positive. Now, if I use pi over 2, I can come in here and put pi pi over 2, cosine of pi over 2 is 0. And so then you got minus 1. So you got negative 1 times your 1 over e to the t. So you know it's going to be negative. And then if I use 3 pi over 2, again, cosine of 3 pi over 2 is 0. Negative 1 makes positive. Positive times 1 over e of t will be positive. So it's farthest left at what? 5 pi over 4, where it starts to change. Now, find the value of constant a for which s of t satisfies this equation. So you got a second derivative plus first derivative plus the original function equals 0. So this is just going to be pure algebra. We're going to get the second derivative. And so you're going to come up here and let's show the work to get the second derivative. So we're going from our first derivative, so I'm going to go from this. So you're going to do product rule, product rule. So if you do that and you get here, this is your second derivative. Okay, so we're going to come over here and we're going to plug a in that plus the first derivative, which we got, plus our original function. And if you work all out, that's going to cancel out. We're going to get this, and I took this to the other side. We'll divide this, and things divide out, and you get 1/2.